Let's start the warm-up. Look at this split screen comparing 52 and 35. We find the heavier side quickly by checking the largest place value first. 5 tens carry more weight than 3 tens. That gives a clear answer. 52 is greater than 35. Moving to the next problem, we compare 30.2% and 31.8%. Because the percent sign appears on both sides, we safely ignore it. We handle these exactly like standard decimals. 31 is larger than 30, so 30.2% is less. At its core, comparing numbers is simply a process of finding the heaviest side. But the formats are about to get trickier. Here is a number line centered on 0, plotting negative 3.58 against negative 5.05. With negative numbers, the value closest to 0 is actually larger. Negative 3.58 has a shorter distance to 0, making it greater. Look at this next comparison, 8.6 versus 8.60. Visually, the right side looks longer. However, placing a 0 at the end of a decimal does not add mathematical weight. Without that empty place value, both numbers are exactly equal. A longer number doesn't automatically mean a larger number. You have to follow the math, not just your eyes. This split screen introduces a format clash, the fraction 5/8 against the decimal 0.58. Our strategy is to divide the numerator by the denominator. 5 divided by 8 turns our fraction into 0.625. With matching formats, 0.625 is greater than 0.58. Here is a heavier mismatch, the decimal 12.5 against the improper fraction 108/8. Applying the same rule, dividing 108 by 8 reveals its weight as 13.5. 12.5 is smaller, making our decimal less than the fraction. Anytime you see mixed formats, converting everything to decimals is the safest path to the correct answer. I'm going to put the next numbers on screen. Pause the video and try converting them yourself before we solve it together. Here is a fraction battle, 2/5 versus 3/7. 2 divided by 5 is 0.4, and 3 divided by 7 is roughly 0.428. Adding 2 zeros to the left matches the decimal lengths. 400 is smaller, meaning 2/5 is less than 3/7. Now look at this split screen, showing 3/4 on the left and 15/20 on the right. Dividing 3 by 4 gives 0.75. Dividing 15 by 20 yields the exact same result. The values match perfectly, so these fractions are equal. Numbers can look completely different on the surface while carrying the exact same mathematical weight. We're stepping into the heavyweight tier. This shows 1 and 1/4 compared to 2 and 6/9. Before calculating fractions, check the whole numbers first. The fractional parts don't matter if whole numbers differ. Since 1 is less than 2, the left side is smaller. Here is our final challenge, 3 and 4/9 versus 3 and 1/8. The whole numbers are identical, so we isolate the fractions. Dividing the numerators by denominators converts the values to 3.78 and 3.125. 3.78 carries more weight, solving the problem. The most complex mixed numbers break down into simple steps. Check the whole numbers, then convert the fractions. You've beaten the worksheet. Let's review our cheat sheet. First, negative numbers work backward. Closer to 0 is larger. Second, ending zeros on a decimal are ignored. Third, when formats clash, divide to convert to a decimal. Fourth, always check whole numbers first. Follow this checklist and you can reliably find the true mathematical weight of any number.